Welcome to this Mathcast. In this episode we're going to be looking at a probability problem that involves some counting rules that we learned back at the beginning of the semester. In order to do this problem, we're going to have to think through what the experiment is and how to count each of the individual occurrences of the event we're interested in. The example that we've chosen to look at is a quality control type problem where we're receiving a shipment of 20 batteries. We know that 3 of them are defective, and we want to know what's the probability that if I was to package batteries from this group, that none of the batteries packaged will be defective. As we start this problem, you want to start first by trying to define what the experiment is. In other words, I want to look at what kind of experiment it is that I'm performing. And probably the easiest way to describe this experiment is I'm going to pull out 4 batteries, or choose 4 batteries. From a shipment of 20. And that shipment of 20 contains 3 defective. Alright, as we go through this, it's often a good idea with problems like this to draw some sort of diagram or to mark out exactly what's going on. And so up here in the corner, I'll just go ahead and say that we've got our batteries. We've got 3 defective batteries. So these are the defective. And then we have good batteries as well. And there's going to be 17 of these in total. And I'm not going to draw all 17. But I will use the computer here to help me out in a second. So there we have 8, and I'm just going to copy these 8 and we'll reproduce them. And then just for good measure, we'll throw in one more here. So here's the good. We've got 17 good batteries. And we have 3 defective batteries. Now this represents, it doesn't represent our sample space, but it represents sort of the foundation for the experiment that we're doing. It's just like if you're rolling a die, you need to know that the die has 6 sides. Here we're looking at the batteries. We need to know 17 of them are good and 3 of them are defective. Now as we get into this problem, what we need to do first is we need to define the sample space. And then after that, I need to define my event of interest. In this particular case, the sample space is equal to the set of all 4 battery groups. Now, there are a lot of ways to do that. We just need to be able to count them. We don't need to necessarily be able to list each and every one of them out. And if I was to count them, since I'm choosing 4 batteries from the group, I don't care the order in which I'm choosing them. This is clearly a combination problem. So I'm choosing out of 20 batteries, 4 to be in a package. That's the size of the sample space. In this case, if you were to put this in your calculator, and I encourage you to check this on your own, it's 4,845 possible packages. So this represents the sample space because any one of those packages is equally likely to occur. Some of them have defective batteries in them, some of them don't. And so what I want to look at now is the event of interest. The event that I am interested in, and I'll just call it the event A. The event A is defined as packages having no defective batteries. And so the question is, how many ways are there to do that? Well, no defective batteries, I'll just kind of parenthetically put this off to the side. This is the same as only choosing from the good batteries. Now, since that's the case, when I go to actually do the work, it seems pretty obvious that the number of ways to do A, the number of things in the event A, is equal to choose from the good. So C17.4. This turns out to be 2380, so 2,380 good packages. If I then try to calculate the probability of the event A, remember the probability of the event A is always the number of ways that that event can occur divided by the number of things in the sample space. We've said that the number of ways that A can occur is 2,380 and that there are 4,845 things in the sample space. If we plug that into our calculator and then reduce, we will get 28 out of 57. Once again, I encourage you to check this. And the decimal will be 0.49123. So it's approximately a 49% chance that if I was to create a package having 4 batteries in it, that package would have no defective batteries. Now there's lots of questions like this that you should be working on right now. And really the key to working these problems comes down to the ability to figure out how big the sample space is, and also to figure out precisely what your event of interest is and how many things compose that event, or how probable that event is. All right, thank you for watching.